Alright, so now we're going to have to talk about the physiology of the urinary system, how the kidneys are actually producing the urine. So we talked a little bit about it before, but so here's one thing, juxtaglomerular apparatus. So this is a structure that regulates the release of a hormone called renin. This renin hormone regulates blood pressure, especially if the blood pressure decreases as a result of dehydration or blood loss. Okay, so this apparatus is actually made up of two different types of cells. Macula densa cells. Know that these are really where the ascending limb of the loop of Henle comes close to the nephron. So we're going to see this on the picture. The other cells, the juxtaglomerular cells, these are the cells of the afferent arteriole, where they come close to the nephron. So here, macula densa cells, these really look at the sodium concentration. And so we're going to learn what that really refers to, but that's really looking at the osmotic pressure of the blood. Then the juxtaglomerular cells, these are looking at the blood pressure, and these are the ones that actually release the hormone called renin. So here we're seeing the corpuscle region. Remember, the glomerular capsule was just the outer part. And so here where the afferent arteriole comes close to the ascending limb loop of Henle, where it comes close, those are called the juxtaglomerular cells. The JG cells they're also called, or they're also known as granular cells. Okay, so again, these are the ones that release the hormone called renin. Then the macula densa cells instead are part of the ascending limb of the loop of Henle. Okay, so you can see how they're close to each other and they're communicating with each other here. Okay, so now next, the urine formation. We're going to come back to the juxtaglomerular apparatus later. The 3 steps of urine formation, filtration, this occurs at the glomerulus. And so this just means that when the blood is coming into the glomerulus filters it and lets out a lot of the fluid, which then goes into the proximal convoluted tubule. Tubular reabsorption, this means that the substances that you want to send back to the body, that you don't want to become part of the urine, these substances go into the capillaries from the tubules. And the tubular secretion is the opposite. These are the waste substances, so I'll just write down here waste or extra nutrients. For example, if you take too much vitamins, well, you're just going to pee them out basically. So waste, extra nutrients, these then go from the nephron, goes into the tubules, from the capillaries. Okay, so now let's look at how this is actually happening. Well, we're going to start with the filtration first. So glomerular filtration, the first step in urine formation. So again, here it's saying substances move from the blood in the glomerulus and into the glomerular space first. So it's that space in the corpuscle basically. So then these substances, the fluid and the substances, will go into the proximal convoluted tubule. And so here it says water, small dissolved molecules are able to get filtered, but large molecules, large proteins, they remain in the glomerulus, and then they're going to continue out the afferent arterioles. The glomerular capillaries, so these have tiny little openings. These little openings are called the fenestrae. So these openings are where the fluid and the different substances come out of the glomerulus. And so then we call the fluid that's coming out of the glomerulus the filtrate. And so the filtrate is basically like the tissue fluid. It just has no blood cells in it because blood cells cannot leave the glomerulus, and it has no large proteins inside. Okay, so once again, the afferent arteriole brings the blood into the glomerulus. So then the glomerulus gets the fluids out, gets the substances out, and then those things go into the proximal convoluted tubule. Whatever couldn't get filtered out, for example, large blood cells, large proteins, and a lot of liquid as well, then go into the efferent arteriole, which will then turn into the peritubular capillaries or the vasa recta that will surround the nephron. The force forcing the filtration, called the filtration pressure. Now, the hydrostatic pressure means what is actually pushing the fluid out of the glomerulus. The net filtration pressure, here it says equals the force favoring filtration, minus the forces that oppose filtration. The main thing that you need to know on this slide, the glomerular capillary hydrostatic pressure. Know that this is the pressure that pushes the fluid out of the glomerulus. These other two, these are actually putting the fluid back into the glomerulus. But these two forces are not very strong. The glomerular capillary's osmotic pressure, this pulls fluid into the glomerulus, and so this kind of uses osmosis because inside the glomerulus, osmotic pressure is higher, so it pulls the water in. And the capsular hydrostatic pressure, this pushes the fluid into the glomerulus also, but this is then due to the pressure. Okay, so here, just a picture showing how the glomerular hydrostatic pressure is the main pressure that pulls the fluids out of the glomerulus, but these other ones, the plasma osmotic pressure and the capsular hydrostatic pressure, are putting the fluids back in. But the net pressure is what's then taking the fluids out. This filtration rate, glomerular filtration rate, just called the speed of filtration. Just know the definition of that. And so it depends on the person, average adult it's saying, and how much the plasma is filtered per day. Now, again, remember, the stuff goes into the glomerulus. I'll just kind of make like a glomerular picture here. The efferent arteriole brings the blood in, efferent arteriole takes it out from here, whatever couldn't get filtered. And so the filtrate is what comes out of the glomerulus into the proximal convoluted tubule. And so what we're going to learn is that a lot of this fluid is going to go back into the capillaries that surround the nephron. So only a small percentage of filtrate is actually excreted as urine. Control the filtration rates. The kidneys can auto-regulate. If, let's say, you drink a lot of water, well then the filtration is going to increase so that you get rid of that extra water that you've been drinking. If you did not drink too much water, then the filtration slows down because you don't want to lose that small amount of water you have in your body to get lost as urine. Okay, so we're going to talk about the autoregulation, the sympathetic nervous system. We're going to learn that the sympathetic nervous system increases the filtration. Then the renin-angiotensin system is more for blood pressure. Okay, and then we're going to talk about these two other hormones that also are important for filtration here. But so first, let's talk more about the renin-angiotensin system. Here, this responds to a decrease in blood pressure, meaning that the problem, the stimulus, is low blood pressure. So this could be as a result of dehydration or loss of blood. Okay, so if this is the case, then renin is released. And so it's getting released by those juxtaglomerular cells or the granular cells. Renin then activates angiotensin first, which then gets activated into angiotensin 2. You don't need to know these two details, just know that renin's activating angiotensin 2. Then angiotensin 2 is going to cause vasoconstriction. Remember, vasoconstriction increases blood pressure because the problem was low blood pressure. Then angiotensin 2 is going to release more aldosterone. We actually learned about aldosterone in the endocrine system chapter. Aldosterone increases water reabsorption, meaning that you're going to send more water back to the body. It's actually doing this by reabsorbing more sodium. And so water follows sodium, we're going to see. Angiotensin 2 also increases ADH, and this one also increases water reabsorption. And also angiotensin 2 is making you more thirsty so that you drink more water. But so all of these are going to increase BP to get the blood pressure back to normal. Okay, so we've learned about the filtration. Filtration takes the fluid out. So now the filtrate is in the tubes in the proximal convoluted tubule, the loop of Henle, the distal convoluted tubule. Okay, so now here are the two other steps that we need to go through to make the urine. Tubular reabsorption, we already saw. This is when the nutrients, water, ions, these different substances go from the tubules and into the capillaries. Most of the tubular reabsorption occurs in the proximal convoluted tubule. Okay, so know that part. Tubular secretion is the opposite. This is when the waste substances or extra nutrients go from the capillaries and into the tubules. Okay, and so this picture is showing reabsorption. So reabsorption means going from the tubes into the capillaries. And so just different substances that get reabsorbed here. Could be sodium, you want to send sodium back to the body, chlorine, bicarbonates, and water is going to follow if there's a lot of sodium in the capillaries. Secretion, the opposite. So now the secretion is when the substances go from the capillaries and into the tubules. Our kidneys like to give up or get rid of potassium through urine. So potassium is very hard to absorb in our kidneys. And so that is why it's good to get a good amount of potassium in your diet. Sodium instead, the kidneys want to reabsorb that.